Good morning, good afternoon, everyone. My name is Shubh. My roll number is 232. I am from D Division, and my topic I'm excited to talk to you about 2D graphic geometric transformations. This is a core concept in computer graphics and animation that allows us to modify objects without redrawing them, saving both time and efforts. We will be looking at the different types We will be looking at the different types of transformations such as translation, rotation, scaling, and then combining at the last. By then you will understand how these transformations help in various applications like graphic design, game development, and even simulations. So moving on to the next slide, what is transformation? Let's start with the basic. So what is a transformation? In the context of geometry, transformation is a mathematical operation that that modifies a object's position, size, or orientation. For instance, we can shift, resize, or rotate an object around a specific point. Transformations are incredibly useful because they allow us to manipulate objects without redrawing them from scratch. This efficiency is critical in fields where objects or uh, modified, needs to be animated or modified frequently, such as in video games, digital graphics, and simulations. By using transformations, we can simulate movement and dynamic interactions in a way that looks natural and fluid. Moving on to the next slide. So there are types of 2D transformation. Now let's dive into the main types of 2D transformation we will discuss today. The first one is translation. Translation is a type of 2D transformation that shifts an object by moving it along the x-axis and y-axis both. Then coming to the second, rotation. Rotates an object about a fixed pivot point. The third one is scaling. Alters the size of an object along the x and y both axes. So we will talk deeply about this all types of transformation. Let's move on. Translation transformation. Let's start with translation transformation. Translation is a transformation that moves every point of an object by a certain distance. This is like shifting an object without rotating or resizing it. So translation simply moves an object from along the x and y axis. Like its formula is the x dash equals to x plus t of x comma y dash is equals to y plus t of y. Whether x dash and y dash are the new position of a point after translation. Here here tx and ty are the distances that we want to move along the x and y axis respectively. Metric form we can represent it by using a transformation matrix, and that is of 3 by 3, and the diagonal elements are 1 and the upper triangle elements are tx and ty. On the x and y axis respectively. Example, thinking of a moving car on a road horizontally or vertically translates allow us to stimulate that movement accurately. Now moving on to the next type of transformation, that is rotation transformation. Rotation transformation. This transformation allow us to rotate an object around a fixed point of often a origin or a chosen pivot. So it can repositions an object by moving it along a circular path around a pivot point. If you want to rotate a point by an angle theta, we use x dash equals to x cos theta minus y sin theta, and y dash equals to x sin theta plus y cos theta. So x dash and y dash are the values calculated after the rotation transformation. This can be shown in the form of a matrix using transformation matrix. The third type of transformation is scaling transformation. Uh, scaling allows scaling allows us to change the size of an object either by enlarging or reducing it. So it shrinks an object, it stretches, or it basically stretches or shrinks an object along the x-axis, y-axis, or both. If we apply scaling factors for the x-axis and y-axis, the formula comes out x dash is equals to s of x into x, and y dash equals to s of y into y, where x dash and y dash are the calculated value after scaling, or they are the new coordinates. The matrix form of this is given by transformation matrix. This matrix multiplies each point's coordinates by sx, and sy to resize it accordingly. Example, think of zooming in or out an image. Scaling allows us to adjust the image size without changing its content. Now moving on to the next. Combining transformation. Combining transformation in real applications, we often need more than one transformation to achieve the desired effect. This is where combining transformation becomes essential. So what is the process? By applying multiple transformation in sequence, we can move, rotate, and resize an object in a complex way. The key is to apply each transformation in the right order to get the desired final result. For example, a common example would be to first translate an object to a new position, rotate it, uh, new po rotate it around a point, and then scale it to make it larger or smaller. Or for example, imagine an animation of car moving along curved path, turning and growing larger as it approaches the viewer. We might first apply translation, then rotation, and finally scaling to achieve this complex dynamic effect. So what do we conclude? So what do we conclude from it? Uh, to summarize, transformations are powerful tools in computer graphics and allowing us to move, rotate, and scale objects. Translation helps us shift objects, rotation allows us to turn object around a point, where scaling changes the size of the objects. By combining these transformations, we can create complex, realistic animations and visual effects. Thank you for listening. I hope you now had better understanding of 2D geometric transformations and how they are used to create dynamic visuals. Thank you.